In this video, we're going to talk about how to construct the unit circle. This is a blank picture of the unit circle. And on this unit circle, you're going to see a location to write the degrees of this interior angle, to write the radian measurement of the interior angle, and to write the ordered pair on the circle for this particular angle. So let's start talking about how the unit circle is constructed. And in the unit circle, the radius, that means from the center point of the circle out to any place on the circle, is 1. It is a unit. It's 1 unit circle. So let's look at pictures of 30, 60, 90 triangle to start with. These are the ratios of a 30, 60, 90 triangle that you've learned. And if I relate this to this picture, I'm going to share that this interior, so this is like a start line. Think of this as a race and you're running around a track. This is always where we start. This is always where we start. And for positive angles, we move upwards. So this interior angle I'm sharing with you is 30 degrees. So if I draw that picture, if I'm going to take this and I go from the center of the circle, which is right here, out to this point. Okay, and I'm telling you that this interior angle is 30. So I've drawn this piece right here. Remember, I've shared with you that this unit circle has a radius of 1. So this length from the center of the circle out to the edge is 1 unit. And now if I go straight down, I can make a right triangle. So if I went straight down here, I would make a right triangle. So if this is 30 and this is 90, remember, the interior angles of a triangle have to add up to 180. 30 and 90 plus 60 gives you 180 degrees. Okay, let's relate that to what we know. Relating to what we know. So this is the basic ratios of a 30, 60, 90 triangle. Notice I have 30 degrees here, so I'm going to look at this picture, okay? They're just in 2 different points, and here we can see 60s down below, and here we see 60s up top. So it's going to relate to this picture down below. And we know again that this length represents the radius of the unit circle, and it's 1. But when I look over here, I see 2x. So I'm going to take 1 and set it equal to 2x. 1 equals 2x. 1 equals 2x, and I divide by 2, and I can see x equals 1/2. So wherever I see an x here, I'm going to turn it into a 1/2. So again, 2 times 1/2 is 1. That's how I came up with this. The x is opposite of 30 degrees, so opposite of 30 degrees is x, but I'm not going to write x. I'm writing the value 1/2. Will this always be the case for a unit circle? It will be. Across from 60 is radical 3 times x. So radical 3 times x. Well, that's the same as radical 3, because radical 3 times 1 is radical 3 over 2. So for any unit circle, across from 30 will be 1/2. Across from 90 will be 1, and across from 60 will be radical 3 over 2. Okay, so I'm going to look up top, and I'm going to do this exact same thing here. I'm going to rewrite this. Across from 30 is 1/2. Across from 60 is radical 3 over 2. Across from 90 is 1. Now watch, I need to follow the same pattern. Across from 60 is radical 3 over 2. Across from 30 is 1/2. And across from 90 is 1. Make sure to write that down on your paper, please. You may be thinking, how is this related to constructing the unit circle? Well, we're going to talk about these ordered pairs. So this is like an x. It's like an x and a y. So I go to the right and then up a distance. I go to the right, up a distance. To the right, up a distance. Okay? Over here I go left and up a distance. So I want to get to this point. Remember, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And although we think of them as an x and y, know that we're going to talk a little bit about it's referred to as the cosine of an angle and the sine of an angle. So cosine is like an x, sine is like a y. Cosine talks about going left and right. Sine talks about going up and down. A lot of students forget, like, do I put cosine first or sine first? And I had a student years ago that reminded me of the TV station CBS, cosine before sine, and that's how they remember what goes first. So let's talk about how do we get to this point. So I've already informed you that this is 30 degrees, and so I'm going to draw this triangle just so it stands out. This is the triangle that I'm referring to. And I want to fill in the accurate ordered pair to get to this point. So first I have to go over this distance. Now if this is 30 and this makes a 90, then this would be 60. So opposite of 60, well, I pull this out. Okay, I want to know what's opposite of 60. Okay, opposite of 60 is the distance is radical 3 over 2. So this distance is radical 3 over 2. Radical 3 over 2. And this distance is opposite of 30 degrees. Opposite of 30 degrees is 1/2. So this ordered pair is radical 3 over 2 and 1/2. That means I go over a distance of positive radical 3 over 2, and then I go up 1/2. Let's now talk about the triangle that you see in yellow. This distance right here is 60 degrees. So if I draw a picture just so you have a better idea of what this looks like, what you see in yellow is just like this. Again, this is the radius of the circle. I know this is 1. I'm sharing with you that this is 60. And then I also know that the interior angles have to add up to 180 degrees, leaving me with 30. So how do I get to this ordered pair? I go over a certain amount and I go up a certain amount. Now, what's this over? Well, it's opposite of 30. Remember, this 30 degrees is only for the green. This is a total of 60. So opposite of this 30 degrees, is this distance. Opposite of this 30 degrees is this distance. So I'm going to go to the right. How far? Well, how do I know the distance of 30 degrees? So find 30 degrees, go opposite. It's a distance of 1/2. That means I go over 1/2, so over 1/2. And then this length is opposite of 60 degrees. It is opposite of 60 degrees. So I go to my picture. I find 60 degrees. Opposite is radical 3 over 2. Once you're able to determine the first quadrant ordered pairs, I'll show you how it's very easy at this time to determine the ordered pairs in the other quadrants. Think of them as a relation like a cousin. This ordered pair representing 30 degrees is going to be very similar to these three. Everything we do relates back to this axis. We think of it as an x-axis, but in trigonometry, remember, x's are really cosines. So this is the cosine axis. We think of this as the y-axis, but really it's the sine. It's the sine. So everything we do relates back to this line. Just keep that in mind. Everything we do relates back to that line. I'll help us to remember that by taking purple real quick, and I'll just make like a little bit of a squiggly line to remind us that everything we do relates back to the measurement, back to what we think of as the x-axis. So this is 30 degrees. That means this is 30 degrees as well, right? 30 degrees, 30 degrees. Here's your right angle. This is also 60. So whatever I have for an answer here, it's going to be the same over here, because I could take this triangle, watch this, and I could just reflect it across the y-axis, across the sine axis, and I'd have the exact same thing. So here I get to write radical 3 over 2 and 1/2. Now what you have to recall is that in quadrant 1, x's and y's are both positive. But in quadrant 2, what we think of as the x, it's negative, and the y is positive. So negative radical 3 over 2 and positive 1/2. Same thing here. This is 30 degrees measured back to this line. This is 30 degrees. This is 60. This is 90. So if I took this and I reflected it up, it'd be this triangle, and I reflected over, it'd be this triangle. It's like they're cousins. So I put down the exact same ordered pair. In quadrant 3, x's are negative and so are y's. So negative radical 3 over 2 and negative 1/2. Remember, these are like directions. Go negative radical 3 over 2, that means go to the left, radical 3 over 2, negative 1/2 means down 1/2. And lastly, if I took this triangle and I reflected it down across the x-axis, I'd still end up with radical 3 over 2 and 1/2. Now, what are the ordered pairs here? In quadrant 4, your x's are positive. Remember, x's are like cosines, and your y's are negative. So they're the exact same numerical values, but what changes to make each one unique, what changes would be the signs, both positive, both negative, and positive, negative. Let's now look at the yellow triangle. So I've created this particular yellow triangle. Notice here I go over a short distance and then up, and I get to this point. Same thing here, I go over a short distance and up, but instead of going to the right first, I go to the left. So these are the exact same interior angles, 60 degrees down, 60 degrees down. I get to take this same ordered pair and put it in place. What's different is we are in quadrant 2, which means the x is negative and the y is positive. In the past, some students say, well, where do I put the negative? Is it in the middle, the top, the bottom? As long as there's only one negative written, it doesn't matter if it's top, on the bottom, or in the middle. Okay, I'm going to come down here, all the way out on this radius of the circle, back to what we think of as the x-axis, and again over here, all the way out on the radius, and back to it. So from the x-axis, known as the cosine, this is 60 degrees and this is 60 degrees. So we're going to have the exact same ordered pairs. So 1/2 and radical 3 over 2, 1/2 and radical 3 over 2. In this quadrant, again, our x's are negative, y is positive. Quadrant 3, they're both negative. Quadrant 4, x is positive and y is negative. Okay, let's move on now to what I refer to as the north, south, east, and west points. And the north, south, east, and west points, in those particular points, you're going to notice that to get to that point, you're going to be using the radius of the circle, which is 1. So this is a distance of 1, a distance of 1, a distance of 1, and a distance of 1. The entire unit circle has a radius of 1. So to get to this point, think of giving the ordered pair like a direction. I move to the right 1, and then I don't go up or down. To get up here, from the center, I don't go left and I don't go right, but I move up 1. To come to the far east, I move to the left 1 is denoted with the negative sign, and then I don't go up or down. Now to come down below to the south, I don't go left, I don't go right, I move straight down 1. What we're missing is right here, and notice this is directly in between 30 and 60. So what's directly in between 30 degrees interior angle and a 60 degrees? Well, in between 30 and 60, I'm just going to write 30 degrees here. In between 30 degrees and 60 degrees is 45. So each one of these that we're going to do now relates to the 45 triangle. That's what we're going to examine next. Okay, let's dive into 45 triangles. So why are we looking at 45? Because I've told you this interior angle down here is 45. When I come straight down, I have the right angle. And so I've added up 45 and 90, and I have a remaining degree measurement of 45 to complete the 180 degrees interiors. So here's what we know. We know that the legs of a 45 are equal. That's why you see an x and x. And this is the general ratio for special right triangles with 45s. So this is going to be x times radical 2. Now we need to convert that just like we did with 30, 60, 90. I took what I know the ratio is and I made it into what it's going to become, knowing that the radius of the unit circle is 1. So I'm going to do the same thing here. I know that this distance from here out to here is 1. I know this is 1. And these are the same parts of the 45 triangles. So 1 is equal to radical 2x. To isolate the x, I'm going to divide by radical 2. And freshman year, you learned that although this is mathematically correct, it's not proper. We don't want any final answer to have a radical symbol in the denominator. So how do we fix that? We multiply by whatever we have in the bottom. So this converts into 1 times radical 2. 2 times 2 is 4, and I know the square root of 4 is 2. Does the 1 just disappear? No, but 1 times anything is itself. Again, 2 times 2 is 4, square root of 4 is 2. 1 times radical is just radical 2. So this is what x equals. So x are the two legs. This is radical 2 over 2, radical 2 over 2. And this is what I'm going to refer back to. So to get to this point, know that this is 45 here and this is 45 here. So this distance is opposite of 45. Opposite of 45 is radical 2. And this distance is opposite of 45. So again, it's radical 2 over 2. As a reminder, it's like it has cousins. This is also a 45, 45, 90. So this is radical 2 over 2, radical 2 over 2. Down here, same thing. Give me 1 second. This is radical 2. And my marker's drying out at me. Very faint, but this is radical 2 over 2. Will it always be the case? Always, always, always for unit circles. But yes, they have the same numerical values, but we need to make them unique. Quadrant 1, everything's positive. Quadrant 2, the x's, which are the cosines now in trigonometry, are negative. The sines or the y's are positive. In quadrant 3, everything's negative. In quadrant 4, the x's are positive and the y's are always negative. Okay, we just talked in this video about how to construct the unit circle with the ordered pairs.